Hello all. Today we'll be going to solve this question this is from organic chemistry. So as you can see, we have been given a ring, a cyclohexane ring, and here we have ET and Br, ET at wedge and bromine at dash, and in this position we have iodine at wedge and methyl group at dash. So the reactant has been given that OH minus, which is basically your the reactant for SN2 or SN1, any reaction. It even this can be even E1 or E2, but this is not E1 or E2 in this case, and that is because we have been given here acetone. This is acetone, right? So acetone is the case for SN2 reaction mainly, because acetone is an protic solvent, so we use that for SN2 reaction. And why we use that, you may Google that, and there's a reason why SN2 for SN2 reaction acetone is used. So anyway, so from that we have figured out that we are going to have a SN2 reaction here. But what will be the product? I mean, we have been given 4 options here. So, and also it is one equivalent, so only one equivalent of OH will react, which means that only one of these bromine or iodine will be replaced. So I mean, we have 4 options here, so we have to figure out, and this is a single correct type, so only one is correct. So yeah, let's do this. Anyway, so to solve this type of questions where we have been given a cyclohexane ring, we always have to first draw a stable conformation of the cyclohexane, because you know that it's not a planar ring and it's basically it's not planar, and we have something like, there are different conformations of cyclohexane. For instance, chair, half chair, boat, twisted boat. So, but the most common one is chair. So let's draw a cyclohexane chair. You probably know this configuration. It is something like this. So, and now we can show the wedge and dashes. So the funda of this problem is that which is the most bulky group in this molecule? This ethyl one. So, and now one thing you have to know, that in a cyclohexane molecule, there are, that there are axial and equatorial bonds, right? So like this, this, or this. So these are axial and equatorial bonds. So now let me tell you one thing, that whenever a bulky group is there, it should be that the bulky group should be always should be in a equatorial bond. So we have to put the ET in a equatorial bond. And why we chose this one? Because for this you can see that it's above the plane and ET was in wedge, so we have chosen a bond above the plane. You may have also chosen this. So in that case, this will be ET and this will be BR. But in this case, we have chosen this. So this is ET, and we have BR here. Okay. And now let's place the methyl group and iodine respectively. So okay. So this is ET, and we have a methyl in the dash. So, and we have 2 carbons. We have to go 2 carbons. It is in meta position respect to ethyl. So now you can see that we get this carbon. You could get this or this, but both are equivalent. So in both cases we get methyl here. In the axial bond. which is of course not stable. Okay, because as I said, bulky group at axial bond is not stable at all, and this should be iodine. So, okay, we have the chair configuration now, and now we can solve this question pretty easily. But you have to know one more thing. Let me erase these bonds. Huh, it's fine now. So what is the thing? We have the nucleophile OH minus. Let me use another color for this. The OH minus is here. Now, the thing is that whenever a bulky group is in the equatorial bond, it is in equatorial plane, the repulsion with the nucleophile, that's very little compared to when it is in the axial bond. So if OH were here, it would have much difficulty to attack in that place because of the repulsion of this methyl group. Okay, so this attack, let me write this here. Um, just a minute. So this attack is not favorable at all. Okay, and what's the reason? Because methyl group is in axial plane. So I mean, from that you already have two options eliminated, right? That OH cannot be here, so this option can be the answer because OH has attacked here, and also this option wouldn't be the answer. Okay, so answer would be one between B and D. And now it's a simple SN2 reaction. Now when OH attacks here, the Br leaves like this, and the uh, configuration is inversed. Okay, so if we construct the product, it will be something like this. Let me construct the chair first, and then we will construct the cyclohexane. So this is the chair, and as due to the inversion of configuration, OH will be here and the ethyl group will go here. Okay, and what will happen to this I and methyl group? So only one equivalent of OH was given, so there will be no change here. Okay, this will be I and this will remain Me. Now one thing is for sure that this molecule, this is our product molecule, but this is very unstable. Why? Because you have two bulky groups at the, you have two bulky groups at the axial bond. Bonded with the cyclohexane with an axial bond. So we can flip the configuration. That's another, that's another concept, flipping of configuration. And the flipping of configuration, it's not important. We already have our answer, but it will look like this. In this case, all the bonds above the plane will stay above the plane, and all the bonds below the plane will stay below the plane. But what happens is that all the axial bonds become equatorial and all the equatorial bonds become axial. So, why is that important? Because you can see that here we have two axial bonds, two unstable axial bonds. So, if we flip the configuration, these two axial bonds will become equatorial. So, this configuration, if we flip it, it will be much stable, and the product will also be stable. So, this was not needed though for our question, but still, let's just draw this. This will be let no let this be ET. Wait, where was, let me recheck the configuration a little. HO was above the plane, so it will be like this, and ET will be like this, and in this bond ME was below the plane, so ME will be like this, and I will be like, let me use a different color for your convenience, this will be I. Okay, so that's our final answer. If we convert that into our general cyclohexane form, that will look like this. So you can draw that OH is like this. Okay, I mean flipping was not important for this question, but I told you the concept because flipping happens in this reaction. So I thought it was necessary that you know that. Okay, so this is it. This is ET, and how will be this ME? This is I, and this will be ME. So this is our final product, and we will now just see which option is matching. Let me type product for convenience, and let's see which option it is. So yeah, it's option D. And why isn't it B? Because you can see we have, I mean, B is a small thing that the configuration hasn't been flipped here. So you can see the only difference between B and D, right? This is the difference, this carbon. So that's why B is not the answer, and our answer is D. So I hope you learned this. I mean, learned the whole concept of this problem. So this was actually a nice one, a tricky one, because many students will get tricked that iodine is a better leaving group and methyl group is a less, I mean, less bulky group than ET. So they might think that this reaction may happen at this center. So they will take the first option, which is completely incorrect. And so for these types of question, I mean, your sole job is to draw the shear form of cyclohexane, and then you have to draw the you have to draw the configuration, the equatorial and axial bonds, and always remember that the most bulky group in the molecule should always stay in with a equatorial bond. And when it is in equatorial bond, the attack of a nucleophile is more favored in that center. And when it is in axial bond, then nucleophile gets a lot of steric hindrance for the attack. So this attack, I mean this one, this big, I am sorry, that, just wait a minute. Okay, so so this attack, this becomes very less favorable. Okay, so that's why this attack happens and inversion happens here, and we finally get this. So I hope you learned the whole concept of this question, and just it was some organic chemistry after a lot of physics. We'll bring more chemistry and probably, if I get the chance, more mathematics too. And but for now there will be physics only, because I have a lot of questions from physics to discuss, from mechanics and from all those chapters you have in your JEE. So for now, yeah, that's it. That's it for today. And I hope you liked the question. I hope you liked the concept. It was a beautiful question, to be honest. And we'll see you in the next video. Thanks for watching. And always, so stay healthy and stay cool.